Hydrophilic versus hydrophobic molecules. This is something that's often used to describe how a molecule interacts with water. And over here you can see in this on the screen, the hydrophobic coating creates a literal ball, essentially, because it's been coated, which is causing all of the whole entire molecular structure to create that sphere, versus the hydrophilic coating is spreading out. It is trying to absorb. Hydrophilic molecules are molecules that are soluble in water, they're polar, and they can combine with water. So if something is soluble, it means that it can combine and or dissolve into usually water is what's usually used. It means that, for example, when you're mixing hot chocolate mix or sugar or salt into water, it will dissolve and disappear usually. So you'll get kind of like the picture on screen, a cloudy glass at first, and then it will become clear again because that salt or sugar or a starch or that hot chocolate mix has dissolved. In the case of the hot chocolate mix, you won't get your clear liquid, obviously, but you'll get a combined solid cup of hot chocolate. And with molecules being polar, that means that they have a negative end and a positive end on the end of their structure. So, for example, think of a battery. On one end, it will be positive, on the other end, it'll be negative. That means it's polar. Versus with a here's some examples of those. So glucose, sugars, menthol, some mints, things like that, are hydrophilic. Something that's hydrophobic, though, this is one that we are all probably familiar with. It is something that cannot be combined or dissolved into water. Something that is hydrophobic, for example, is oil. We've all done that really fun experiment as a kid, or I know I did. I know it was a common thing where I grew up in my area to make lava lamps out of like a pop bottle. So all you needed was water, food dye, oil, and usually we used a seltzer tab or like I can't remember the name off the top of my head, but the things you, like denture cleaner, they're the tablets you can drop in water and it makes the water fizzy. But we used those few ingredients to create a lava lamp because your oil would never mix with your water, so that would cause the now dyed water and the oil to be even more distinct than they normally would be, which then you can see the oil move and flow as you would expect from the lava lamp. They weren't always amazing and they didn't always work the best, but it taught that basic principle. I made this in elementary school, I believe, for science fairs and a few other just random occasions. But that's a really good example of something that is hydrophobic. We know that molecules are hydrophobic because they won't dissolve in that water, and they are not polar, so that means that the ends of their structures are the same, so you'll have a negative and a negative on both sides. So for example, if we had a negative and a negative on a battery, it wouldn't work. There's no charge, it can't polarize anything. So that is hydrophobic. Hydrophobic examples, again, there's that oil and that lava lamp. Another one is duck feathers. Ducks create their own oily coating that they wear on the outside of their feathers, which then makes it so that they can swim and dive and fly and not be affected by the water. And then here are my references.